Hi viewers, welcome to Interesting Chemistry. In today's session, we are going to see the important concept of chemistry, stoichiometry. Till 10th standard, we haven't come across this word stoichiometry. First, let us understand what is stoichiometry. Stoichiometry means the quantitative relationship among the reactants and products in a chemical reaction. Chemical reaction means definitely reactant will be there. That reactant will be converted into product. This is nothing but chemical reaction. In this chemical reaction, how much quantity of reactant undergone a change and it produces how much quantity of product. If it is explained, that is nothing but stoichiometry. The stoichiometry coefficient. The stoichiometry coefficient can be interpreted in many ways. What is that coefficient? Coefficient is a numerical number placed before the reactant and product in a chemical reaction. That is nothing but coefficient. The numerical or number placed before the reactant and product. So let us take one example. Real chemical reaction can be taken as an example here. N2 in the form of gas plus 3 molecule of H2 in the form of gas, it produces 2 NH3 in the form of gas. Here no number, that means 1. Here 3 molecule of hydrogen. Here 2 molecule of ammonia. So this 1, 3, 2, these are nothing but coefficient. Coefficient means the numerical which is placed before the reactant and product in a chemical reaction. So these are the coefficient. 1, 3, 2 are the coefficient. This can be expressed in different ways. The quantity can be expressed in different ways. Here one molecule of nitrogen combined with 3 molecules of hydrogen. It produces 2 molecules of ammonia. This is one way of interpretation. First way of interpretation, let us take in terms of molecule. 1 molecule of nitrogen combined with 3 molecule of hydrogen produces 2 molecules of ammonia. Second, we will take in the form of molar mass. Nitrogen, its molar mass is 28 gram. So 28 gram of nitrogen combined with 1 molecule molar mass of 1 molecule of hydrogen is equal to 2 gram. That is 1 mole of hydrogen molecule mass is 2 gram. So 3 into 2 gram of hydrogen gives 2 into here molar mass of ammonia 14 plus 3 17 gram of ammonia. This is second way of interpretation. Then third way, this 28 gram of nitrogen is nothing but 1 mole of nitrogen. So 1 mole of nitrogen combined with Here 3 moles of hydrogen. 6 gram means 3 moles of hydrogen gives 2 moles of ammonia. 2 moles of ammonia. This is third way of interpretation. Next, fourth type. In terms of molecule, 1 mole of nitrogen is nothing but it contains 6.023 into 10 power 23. Here only one molecule, but if we take 28 gram of nitrogen, it contains 6.023 into 10 power 23 molecules of nitrogen combined with 3 into 6.023 into 10 power 23 molecules of hydrogen, then 2 into 6.023 into 10 power 23 molecules of ammonia. Here it is one molecule. If we take 28 gram, it will be having these many molecules. Then fifth way, if the reactant and product are in gaseous form, we can take this one in the form of volume, because at STP 1 mole of a gaseous substance will occupy 22.4 liter. So here 22.4 liter of nitrogen combined with 3 into here 3 moles. 1 mole will occupy 22.4 liter means 3 moles will occupy 3 into 22.4 liter of hydrogen produces 2 into 22.4 liter of ammonia. So, the same chemical reaction can be interpreted in many ways. In the form of 1 molecule, 3 molecule, here gram, here 1 mole. 1 mole contains 6.023 into 10 power 23. So, in the form of number of molecules, then volume 22.4 liter. The problems based upon chemical equation. The problems based upon chemical equation can be classified as mole to mole relationship. Mole to mole relationship. Second type, mass to mass relationship. Third one, mass to volume relationship. Fourth one, volume to volume relationship. What may be mole to mole relationship? In these type of problems, the moles of one of the reactant and reactants will be given, and the mole of other reactants or products will be asked. That is mole to mole relationship. One of the reactant or reactants mole will be given. The other reactant or product mole will be asked. This is mole to mole relationship. Mass to mass relationship. In these type of problem, the masses of one of the reactants or product will be asked by giving the mass of reactant or product. Then third one, mass to volume relationship. In this, mass will be given, volume will be asked, or vice versa. Then fourth type, volume of one of the reactants or products will be given, volume of one of the reactants or products will be asked. In this way, different types of stoichiometry sums are possible in chemistry. It is very important part in chemistry. These type of calculation, stoichiometry related calculation is very important. In some of the sum, it will be asked directly stoichiometry calculation, or in some of the sum, it will be a preliminary calculation. By using that preliminary calculation, we have to find out some other things. So, it is very important in chemistry. The main steps involved in stoichiometric calculations. In stoichiometry calculation, first step, you should write the balanced chemical equation. Balanced chemical equation, first it should be written. Second one, finding the correct relationship. Finding the correct relationship to be used in the calculation. Finding the correct relationship. What relationship we are going to use here, whether it is mole-mole relationship or mole-mass relationship, volume-volume relationship, mass-volume relationship, which relationship we are going to take in this stoichiometry calculation, that we should find out. Third one, apply the same relationship. Apply the same relationship in balanced chemical equation also. The same relationship, we have found out the correct relationship here. The same relationship we are going to apply in the balanced chemical equation also. Then next step, after applying the same relationship in balanced chemical equation, write the actual quantity of the of the substances which take part in a chemical reaction. So we are going to write the actual quantity of the substance given in the sum problem. Next, fifth one, calculation. Calculate the result by using the balanced chemical equation by a unitary method. First we should write balanced chemical equation, and we are going to find out in which way they have interrelated. Mass and mass they have given, or mass and volume, or volume and volume, in what relationship they have given the values. Next, apply the same relationship in balanced chemical equation also. Then write the actual quantity of the substance given. Last, we are going to calculate the result by unitary method. This is the way to find out the result in stoichiometry calculation. We are going to see few sums based on this in the next video. Thank you.